Hey everyone, welcome back to the channel. Today we are on site at the Department of Adult Education, University of Ibadan, a place that's extra special to me as a proud University of Ibadan alumnus. We are here to showcase another clean energy transformation, a complete solar installation project handled by Aksun Electronics Technologies Limited. Alright, as we arrive on site, the first step is bringing in all the essential materials for the installation, from high-efficient solar panels to the mounting frames, cables, batteries, and the inverter system. Everything is carefully transported to ensure safety and quality. Our team begins offloading each component with precision, making sure nothing is damaged and every item is accounted for. This stage sets the foundation for a smooth, successful installation. Now, it's time for one of the most exciting parts of the project, unboxing the core components. We start with the inverter, and for this installation we are using the 8 kW Felicity inverter, a reliable high-performance unit built to handle heavy loads with excellent efficiency. Every part is inspected carefully as we take it out of the box, ensuring it is in perfect condition before setup. Next, we move to the battery, the heart of the system storage. For this project, we are installing a 15 kWh Africell Lithium Battery, known for its long lifespan, fast charging, and strong backup performance. Unboxing this unit is all about checking the terminals, confirming the voltage, and preparing it for a clean and secure connection. After unboxing, we move both the inverter and the battery to their designated installation points, ready for proper alignment and mounting. With these core components set in place, we can move on to the next stage of the installation. Next, we move on to preparing the cable pathway, starting with the layering of trunking pipes on the wall. Our team begins by marking the exact route where the cables will run, ensuring everything is neat, safe, and professionally aligned. We then drill the wall at a strategic point, creating clean holes that make screw and nailing the trunking fast, secure, and durable. This step is very important because properly installed trunking keeps all cables protected, organized, and looking clean throughout the entire solar system setup. After preparing the trunking, we move straight to the mounting the inverter. The 8 kW Felicity inverter is carefully lifted and placed against the marked position on the wall. Our team drill precise hole, insert strong wall plug, and securely hang the inverter to ensure it stays firm and perfectly aligned. This step is crucial because the inverter is the control center of the entire solar system, so it must be mounted safely, neatly, and professionally. With the inverter securely mounted, we move on to the next critical stage, making the wiring connection. Our team carefully routes each cable through the previously installed trunking, connecting the solar panels, inverter, and battery system with precision. Attention to detail here is key, as proper wiring ensures the system operates safely and efficiently. At the same time, we set up the protection box, which safeguards the entire installation against overvoltage, short circuits, and other electrical issues. This step guarantees both system longevity and user safety, giving the customer peace of mind with their new solar set. While the wiring connections were being done, another team was busy mounting the solar panels on the roof. For this project, we used 16480 watt Africell solar panels to ensure maximum power generation and efficiency. Although we couldn't capture the step-by-step process because all hands were on deck, the video clearly shows how neatly and professionally the panels were placed and aligned on the roof. At this stage of the project, our team leader stepped in to take us through the full setup. He explains how the components were connected, how the inverter communicates with the battery, and how energy flows from the solar panels into the system. This walkthrough helped the client understand the installation better and highlight the level of expertise and precision that went into every part of the project.
Snake installation. So now let me put you through what we have here. So a call was given to us from this department, adult education, so that they want something that will be able to power this office. Can you show us the camera? This office, and then we have this is the office, we have the secretary office, and then we also have offices of the staffs. So right here we have offices for this. This is secretary office before you get into the HOD office, and then we also have some other offices for the staffs. You know, so now we want something that we'll be able to use as an alternative backup for our presentation in the right in this button. There will be a time they want a presentation and they don't interruptions of power supply, so they want something that will be so, and then we said we came from audit and we did our calculation and we came to a conclusion of 8 kilowatts to power. We have about, apart from this room, we have about 12 offices, so where we give them each outlet a socket and a lighting point just to power their system and a small standing fan. So here is the main control, and let's just go through this. So we just finished completing this installation and preparing the system for the very first time. So let's go through this. So I'll be putting on my lithium battery. I love this new aesthetic design of Africell. I love this design. So it looks sleek. And though it's 1 month, but we didn't install it in a 1 month. We like, let's have our own position in a new way. So let's put it on. So now the battery is up. So we are having an SOC of 98.9%. The battery voltage is 53.9. Now let's put on the MCCB. Yeah, that's MCCB right there. Don't mind this. In our protection box here, this stands for our grid. This is for our grid. So there's grid currently, as you can see, there's grid currently. So that is why we are having this coming up. But the grid input is still off. But this is just the AVS for the grid. So then we have the output surge, and then we have 3 different AVS for the output distribution. One is for this office right here, powering this office and the secretary office, and then we have one for 6. We channeled on 6 offices on one, another 6 offices on another one, so that we can have a control over the loads on it. So here is our protection box for our PV. So we have 2 strings. The Felicity Inverter Solar comes with, like, I love this design. So it comes with 2 strings of solar. You can see this strings 1 and this strings 2. So in fact, there's one special thing I love about this design. It comes with Wi-Fi inbuilt, not external dongle. Inbuilt, this antenna right here. Inbuilt. So which means I can communicate and then read readings from this system anywhere I am in the world, provided I have internet here. So I'll be putting on our PV. We have up there, we have 16 pieces of 180 watt solar panels. So we have 8 on one string, 8 on the other string. So let's put on PV1. Should come up. Yeah, system is up. Now you can see everything. You see from the screen that PV1 is reading here right now. PV1 is reading, and you see that the charging has started. Let me put on the second strings. So now, can you see PV2 is up also? So, and I can view the information of coming from different arrays of our PVs. So let's do that. Battery is 54. Battery is charging currently with 18 amps. PV1, we have 220, 230 volts, and then PV2 220, 217 volts. That's cool. Then PV1 is charging currently with 513 watts. PV2 530 volts. So the time now is around 4 thereabouts. So I think that's why this is this, or maybe let's say because the batteries will do. I've not done my settings, we'll be doing that together now. So so this is the protection box for PV1, PV2. If they have their DC surge individually also. So that's that. So our system is charging. Now let me put on the system also for the very first time. The switch is by the side here. Okay. So it should come up any moment. Yeah, our system is off. Our system is off. Then our 3 AVS should come up. Should come up once I load it. Let's do that. These are our light switch. These are our light switch. We did the connection such a way that if I place our hub is grid, then why our down is on this. So I place on this. Can you see now? So our 3 AVS are on. So I'll also be doing the settings for this 3 AVS now. And but let's start with our settings for the inverter first. So for settings for the inverter, you have to go in this. You have to press down the enter button. Okay, and then enter. Okay, and then down. The first one is our output voltage. Remember, 220. That's cool. So let's do that. 220. 20. Enter. And then now the next frequency 50 Hz is okay. The next that's setting steady from the manual means utility input range. So remember I said during our last videos APL is for more wider range, but while UPS is for more narrow range. So I like going with UPS. So UPS, and then number 4, our output source, like your load. How should your priority of your load be? USB means utility first, solar and battery. So which means if there is utility, like the way there is utility now, your load, if I apply these settings, it means that my load is going to be on utility, and if there is no utility, it falls back to solar. If there's no solar, it falls back to battery. But what I like using is SUB, which means solar first, utility and battery. So which means if once day breaks and there's solar, it falls, our main priority is solar. But once the sun goes down, it falls to grid. That is if grid is available, and if there is grid not available, it falls to battery. So let's do that. So change it to SUB. That's SUB. So and then the next one, number 5, is charging priority also. Remember I said I like using CSO. CSO means PV will charge battery first, utility will be second, and if utility is not that's if PV is not available, utility charges. So that's mean CSO is the best. So I like using that. So that's CSO. And the next is 6. 6 means max charging current. That is utility plus solar. So the default here is at 10. We increase that to 60. For this battery, I can charge with maximum of 100 amps, but I like doing 80 because of my battery cells and BMS. So 80 max is okay. Then for utility charging, 10 amps is okay, so that I won't be drawing much from our utility. Then for this is 08, setting 08 is battery type. We're using user. We're using user because we are using the Felicity battery and premium Africell battery. So since I'm not using the same brand of battery this time around, and I'm not sure Felicity will communicate with Africell. Africell is a new brand in town, so I'll be using my user settings. Setting 9, that's bulk charging voltage. So what I do here is that you have to check the type of battery you are using. Check the type of battery you are using, and you check their bulk. Whichever type of battery you are using, the bulk voltage will be specified. It's going to be specified in the manual or on the tag on the battery. So based on my manual here, our bulk charging is 58.4. 58.4, so let's do that. So 58.4 we save. And the next one, float charging. Float charging. Remember, this is a lithium battery, so it's always advisable you choose a nominal voltage for your float charging. So based on my type of battery here, my brand of battery here, our nominal voltage is 51.2. So 51.2, right? So the next settings are 11. Let's check it out what it means here. Okay, low cut-off voltage. That is the level at which our inverter shuts down. You have to follow whatever the manufacturer of the battery also gives as a recommendation. Based on this, the recommendation is 40, but I will leave it right on 42. So that means we have 2 volts clearance. If I'm shutting down exactly 40 volts that the manufacturer of the battery said I should shut down, that means I'm shutting down at the same level the BMS of this battery is to shut down, and which can affect the BMS of the battery. There are some batteries that once the BMS shut down, to recover back, you have to boost charge the battery for the BMS to recover back. So it's always said that you don't shut down exactly the same recommended voltage that is specified by the brand, so as not to be having issues with your BMS. So you have voltage clearance of some installer might say 4 volts, but I think if my brand's designer is saying 40 volts, 42 volts is okay. So let's go. Then the number 12, we have battery setting. I think I can leave this to where it is. It says here to also where it is before. All these are maybe you want to set dates, time, but I'm not sure I needed that since I'm not monitoring over the internet. It's a system that is used by an organization. So settings 34, 35. So I think 30, 31, 34, 35. Okay, 35 is for, every hybrid system comes with 2 output options. So we are using just single output option here. So we leave that the way it is. So 36, same way is for SOC percentage for the second output, since we are not using that. So I think that's that for that. So I save, I return back. Let's check the second. Okay, this is if I want to check details of the one installation, how many kilowatts it charges and all that. So I think that's that. So we're done with the settings for the inverter system. So now let's go to this, our ABS. Now let me do some explanation concerning our ABS because of our viewers. But this applies especially to installers. Like there was a video I did one time, and then I got a question from someone from our YouTube page that how do I do my ABS current settings? How do I do my ABS current settings? Now this is it. It's simple. Now remember we said we are installing an 8 kVA inverter. So all you just need to do is go to your calculator and then remember power equals voltage times current. Right? So if I'm going to get the current to set for my ABS here now, I need the current. Now the maximum current the system is going to be drawing. So 8,000. Based on the power factor of this product, I think most of them usually use 1 as a power factor. But me, I like using 0.8. I don't like going with their own maximum power. So if I'm removing my power factor, that is times 0.8, that is 6,400. Now divided by 220, PV plus IV. My current will now be P over D divided by 220. That's 29. So which means to safeguard my system, it will be better I don't draw more than 29 amps from this system at a go. Now since I'm splitting my digital protector here, right? So I'm going to divide 29 now. I want to split in such a way that, you know, I told you we have 12, we have 6 office on each of these. So I'm going to place my main current on this. When I divide 29 by, let me see that means it's 7 amps each. So let me place 7 times 2, that's 14. So let me give my main one, which is this main office here. Let me give it 14 amps. And while I give others 8 amps. So let's do that. Now let's go. So now we have our menu here. We just press your menu. Then the first settings is up. That is over voltage. So I like using, for my over voltage, I like using 245. So which means if it senses any voltage higher than 245, it cuts off. The next is low, under voltage, that's low. I like using 185. Sorry, I have to start again. 185. So which means if you sense anything lesser than 185, it's cuts off. We have our current. Remember we said we are using 14 here, so I'll bring it down to 14. So which means whichever load is being powered under this ABS, for every load that's under this ABS, if it tries to exceed 14 amps, it shuts down. So it protects the system. So I think I'm done with that. So I move to the next one and do the same thing. Bring this down to 2.5. Remember I said let's do this one for 8. So this is from the first ABS for my grid. I'll also be doing my settings for my grid also. The grid is now a priority for this design. Solar is my priority. So 8, I think we'll go with that. So I move to the last one, also 8.
And here it is, the final setup. A clean, organized and beautifully arranged solar power system. Everything from the inverter to the battery bank, wiring and protection box comes together perfectly, delivering a professional finish we are proud of. What a beautiful setup. Thank you for watching this installation journey. If you want a clean, reliable and professional solar installation like this, kindly reach out to us on 070-3244-0596 Aksun Electronics Technologies Limited.